Going to be part 2 for our review on applications of integration. So we're picking it up with question number 14. All right, so question 14 gives us this kind of sketch of what's going on between the x and y axes, horizontal line y equals 1, and the graph of y equals the natural log of x. All right, so I'm going to go into Desmos. I'm going to go ahead and type all this in. All right, and we can figure out how to find the volume of the solid generated when you take this and you revolve it around the y-axis. So I'm going to type in to Desmos. We've got y equals the natural log of x. Then we've got the axes. So we've got x equals 0, y equals 0. And then we have, I believe it is y equals 1. Okay, and let me zoom out a little bit so you can see how this. Okay, here we go. So there it is, just like it looks on the actual paper. All right, and the key thing here is when you do this, right? I'll show you the formula sheet here. But the key thing when you do this is in addition to what was already on the integration formula sheet from the last test. All right, when you do this, it's saying to revolve it around the y-axis. So that's kind of the first kind of thing, and make sure you're honed in on which axis you're revolving around. So I'm going to be doing the integral from 0 to 1, right? Because my y-axis right there is 0 to 1, okay? And I'm always going to put the pi out front in terms of finding this volume. And then the formula I'm actually using, all right, is going to be this dis method along the y-axis where I'm going to square my function. Now, here's the tricky part. All right, I mentioned that in our lesson that the AP exam is going to try to mess you up like this. But if you notice, this is the function they gave us, all right? But I need to rewrite this in terms of my y's because I'm revolving around the y-axis. So when I write y equals the natural log of x, I'm going to solve for or isolate for x. So what I need to do is I need to take the inverse operation of the natural log of x, which is actually the e to the power of each of these things. All right, that's why I put this on the review. That's a little tricky. So e to the natural log of y, all right, and then you guys learned in pre-calculus that natural log has a base of e, and when your big base and your little base are the same, you get x, whatever that argument is, in this case x. All right, so now, instead of writing the natural log of x, I'm writing e to the power of y. I'm squaring that, and I'm doing dy. All right, that's the integral from 0 to 1 of e to the power of 2y dy, again, all times pi. Let's find the antiderivative using our integration formula sheet. You'll see up here, the integral of e to the x is just e to the x. So kind of like we've done in the past with other ones where you have powers, you need to make sure that you're doing the chain rule here. So if I do e to the 2y and then take the derivative of that, I actually get e to the 2y and then times 2. So I don't want that times 2, so I just throw a half out front. Evaluate this at 0 and 1, and then again, all of that will be multiplied by pi. All right, so I have 1/2 times e to the second power times 1 minus 1/2 times e raised to the 2 times 0 power. All right, that's going to be 1/2 e squared minus, and anything to the 0 power is 1, so this is minus 1/2. All right, again, all of this is going to be multiplied by pi. So this is my answer. And if you wanted to clean it up a little bit, you're going to have e squared minus 1 over 2. So cleaning up would be e squared minus 1 over 2, and then all of that times pi. So let's see. That's going to give me letter B. So 14 is letter B. Let's go to 15. All right, so 15 says we have a triangular region in the first quadrant. Let's draw a little sketch here. All right, where it's 0, 0. This is A, comma 0, and then 0, comma B. All right, and this creates a triangle. And they are, let's see, we're revolving this around the x-axis, and we're trying to find the volume that's generated by this. All right, so again, the integral from 0 to my A value, all right, so whatever it is, or it can be any number. And then it's the pi, which I'm going to throw out front, times the function squared. Well, the function in this case is just a line. So if I can find the formula for that line and then write it as squared times dx, I should have my answer. All right, well, I know the y-intercept is going to be b, so it's going to be plus b here. All right, and then to find the slope, I'm going to do the change in y over the change in x. So b minus 0 over 0 minus a. So that's going to be b over negative a, or rewritten as the opposite of b over a. So in this case, it is negative b over a times x plus b squared dx. So I'm looking for this answer in terms of number 15. So let's see. Looks like D is going to be my answer for number 15. All right. There's another way to do this. You could, if you wanted to help yourself out, if this is a little confusing, you could make up numbers for A and B. And if I would do this, I'd probably use A is 2, B is 4, or vice versa. A is 4, B is 2, your choice. Again, you'd find the same thing once you convert it back to your A's and B's. Okay, 16. It says, what is the volume of the solid generated when the region in the first quadrant bounded by this natural exponential function, the x-axis, and the vertical line, x equals the natural log of 2, is revolved around the x-axis? So I'm going to go to Desmos so I can sketch what this looks like. So I'm going to type in the natural logarithmic exponential function, e to the power of x. So e to the power of x. And I'm looking at the x-axis, which is y equals 0. And we have the vertical line, x equals the natural log of 2. All right, so you can kind of see this. We're revolving around the x-axis, so that's nice. I don't have to do any changing since it's not the y-axis. And so it looks like it's just going to be the integral from 0 to the natural log of 2 of my function squared. So that's going to be, my function is e to the power of x. So the integral of 0 to the natural log of 2 of my function squared, which is e to the power of x squared dx. Don't forget to throw pi out front. So the antiderivative for this is going to, well, actually, let me do a little more work first before I do the antiderivative. So that's going to be e to the 2x power times dx. Now we're ready for the antiderivative. Like I did before in one of these problems, I think it was 14. When you do the integral of e to the power of 2x, make sure that you throw that 1/2 in front, because chain rule, you would need to multiply by that derivative of 2x, which is 2. And this is evaluated at 0 and the natural log of 2. And again, all of this is multiplied by pi. Okay, so now I'm going to do 1/2 times e to the 2 times the natural log of 2 power minus 1/2 times e to the 2 times 0 power. Now this one's going to be a little tricky here, but you can see this is going to be, if I use one of my powers, all right, one of my rules with logarithms that you went over in your junior year, you can take this 2 and actually move it to the back. It's called the power property, to be the natural log of 4, right? 2 squared is 4. And then we already went over e to the 0 power is 1. So this is going to be minus 1/2. All right, now just like I did earlier, there's a little base e there, so that's going to be 1/2 times just a big 4 minus 1/2, which is equal to 2 minus 1/2, which is going to be 3/2. All right, remember, don't forget, at the end of the day, you have to multiply that by pi. So when you multiply it by pi, you get 3 pi over 2. So 16 is B. Okay, 17. All right, so another one of these where we are revolving around the y-axis. So I'll sketch it. I don't really think you need to sketch this one, but just to continue with what we've been doing, I will sketch it. So we have the square root of x minus 1. And we have vertical line x equals 10. All right, and the x-axis, so y equals 0. Zoom out so you can see all of it. There we go. And we're revolving around the y-axis here. So the first thing I do whenever I look at revolving around the y-axis is I want to see what this point is, which is 10, 3. So when I do my revolving, my integral, I'm only going from 0 to a y value of 3. So that's kind of the first thing I think of when I'm making this integral. So I'm talking about having from 0 to 3. All right, again, I put my pi out front. So haven't even really done much work, but A and B are going to be wrong because I'm looking at around the y-axis for my revolution. So that's 0 to a positive 3. Now, the other thing I need to do is I need to rewrite what they gave me in terms of my x. So right now I have y equals the square root of x minus 1. I'm going to isolate x by squaring both sides and then adding 1. So this is what I have now for my other piece. All right, in terms of y squared plus 1. So I know you can notice, you'll see the y squared plus 1, each of those. Now, the last thing is to do the formula. Now, the formula here, we go down here, is when you're doing along the y-axis for our washer method, right here, the second to last one, you'll see we have the first function squared, which is the one on the right, and the second function squared is the one on the left. So if you look at our sketch, the one on the right is actually our vertical line, x equals 10. So we have 10 squared. So 10 squared minus y squared plus 1 squared, and then all of that times dy. All right, so when you do 10 squared, you get 100. And when you square y squared plus 1, you just write it as y squared plus 1 squared times dy. So that's why 17 is D. Okay, 18. All right, we have the base of a solid is the region in the first quadrant bounded by the graph of 2x minus x squared and the x-axis. So I'll sketch that so you can see what we're looking at. So 2x minus x squared. Sorry about that. All right, so 2x minus x squared. And then it says the x-axis, which is y equals 0. Zoom in so we can take a look. All right, and we're revolving this around the x-axis. All right, and it says in the problem that the cross-section we're going to use is a square. All right, so when I'm thinking about the area of a square, we did this in one of the first examples in lesson 6.2. The area of a square is side squared. So when I look at my sketch, right, you'll notice that if I do a cross-section here, my side length, one of them, has to be this function. So if all of the sides are the same when you do side squared for the area, you have the function squared. So it's going to be the integral from 0 to 2 of my function squared, 2x minus x squared, and then all of that squared dx. So I'm going to get that to be squared. So if I square the first one, that's 4x squared. The middle term is you multiply the two terms together and then multiply it by 2. So that's going to be minus 4x cubed. And then the last one squared is plus x to the 4th power. All right, so this would give me the volume of this solid. All right, so I'm going to do the antiderivative of this and get, that's going to be x cubed. I want it to be a 4, so 4/3 x cubed. This one is going to need to be x to the 4th power. But when I do the derivative of that, I get 4x cubed, so that's fine. And then plus 1/5 x to the 5th power. All evaluated at 2 and 0. Now, I only need to evaluate at 2, and I should get my answer. So 4/3 times 2 cubed minus 2 to the 4th power plus 1/5 times 2 to the 5th power. Again, you can go to Desmos at this point and type it in. So that's going to be 2 to the 3rd power is 8. Times 4 is 32/3 minus 16 plus 32/5. All right, if I get a common denominator for the 16 with 32/3, that's going to be 32/3 minus 80/3. Oh, that's not right. What's that going to be? That's going to be times 3 is going to give us 48/3. All right, which is going to be negative 16/3. So that now needs to be added with 32/5. If I get a common denominator for that, that's going to be 15. Again, you can go to Desmos at any point here. That's negative 80 over 15 plus, what's that going to be? That's going to be times 3 would be 96. So that's going to be 16/15 for this one. Let's see if I got that. 16/15 So 18 is going to be C. All right, let's go to 19. Very similar problem to what we just did. It's just they're telling us that our cross-section is going to be a semicircle. All right, so you're going to see how this changes it just a little bit. So let me graph it for you. We have x cubed and the x-axis. So x cubed and the x-axis, and we're going from 0 to 1. So x equals. All right, so again, when you look at the cross-section here, this is going to be one of the tougher problems to explain, so I'm going to do my best here. But if we looked at the cross-section being a semicircle, right, so a semicircle here, then we would have the diameter for our circle would be y, all right, would be our function. All right, so let me write that down in terms of the area formula. So our area formula for a semicircle is pi r squared over 2, right? So half of that. And when I write this down, it's going to be pi. I'm going to move the over 2 with the pi, and then times the radius squared, which is going to be our y value, right, or our function, divided by 2, because our diameter of this circle is actually going to be our function. So now if I replace this as y squared over 4, I end up getting pi over 8 times our function squared. So watch what I do for the integral. So the integral, to find the volume of this, is going to be pi times the integral from 0 to 1. And I'm going to put that pi over 8, all right, when I move it outside, all right, times our function squared. So x cubed, all of that squared, dx. All right, so that's going to be x to the 6th power that I'm finding the integral of. So that's 1/7 x to the 7th power evaluated at 1 and 0, which should be pretty straightforward, right? Don't need to plug in 0, so you get 1/7. Again, that's not my answer because you need to multiply by pi over 8. All right, which gives me my volume of pi over 56 units cubed. All right, so 19 is A. Again, I think the hardest part is figuring out what you're going to be using as your kind of formula for the area. So this kind of first part that I did is the trickiest. So watch how I do this for the next couple, and I think your brain will start to sort it out. Let's go to 20. Okay, very similar problem, but this time we're talking about a quarter circle, okay? So now when I have the area, it's going to be pi r squared over 4, right? Quarter circle. Like I did before, I'm going to put my 4 with underneath my pi, and then it's times, and just like I had before, it says the center of the circle is on the x-axis. So my, in terms of my diameter, right, my diameter is going to be like 2 of that, okay? So when you're doing this, right, we're looking at, you know what, I didn't even sketch it. Let me sketch it first and kind of show you what I'm talking about. So let me sketch x squared and the x-axis in 0 to 1. So very similar to the last problem. Don't need to change really a whole lot. So let me change this to x squared. I'm actually good. Okay. So what they're telling us is that the center of the circle is going to be the x-axis, and the radius is the distance to our actual function of x squared. All right, so my radius is going to be x squared. So when I'm doing this, x squared is the same as y. So I'm plugging in y for my radius squared. So that's going to end up being pi over 4 times y squared. So when I do my integral to find the volume, I put my pi, right, my constant here, pi over 4 out front, times my function squared, which is x squared squared times dx. So that's pi over 4 times the integral from 0 to 1 of x to the 4th power dx. Now you guys know how to integrate that. It's going to be 1/5 x to the 5th power evaluated at 1 and 0. Hopefully pretty straightforward. You don't need to plug in 0. So that gives you 1/5, but don't forget we need to multiply by our constant, which is pi over 4. Multiplying those together will give us our volume, which is pi over 20 cubic units. So 20 is A. All right, and our last one. All right, our last one says we have the region bounded by the graph y equals e to the negative x power. So let's plot that. So e to the negative x power. And also by the x-axis, x-axis. That's y-axis. Here's the x-axis. Right, and then it says some value x equals b. I'm just going to put x equals 3 for now, just so you can like visualize it. I'll make it 2, it's a little easier to see. Right. Again, it's probably, I don't know what it is, right? I don't know what the answer is, but if you visualize it, this is what I'm saying when we rotate it around the x-axis. So to find this volume, right? To find this volume of this one, I'm going to do the volume is equal to the integral from 0 to b, right? I don't know what it is. If you look at my sketch on Desmos, I put 2 for b, but I don't know what it is. So 0 to b, all right? And then we have our e to the negative x, all of that squared, all right? Because if we look at our sketch again, all right, this is our function e to the negative x. We're using that formula that says that we should square it, okay? And then we are going to put dx. All right, it also mentions that our cross sections are squares. All right, so you guys know that if our side length is the function y equals e to the negative x, we have e to the negative x times e to the negative x, or e to the negative x squared. All right, so that's kind of where they get that, that whole idea of that formula. So if I go ahead and distribute that, e to the negative 2x power dx, all right, and then I want to integrate. So I get e to the negative 2x. Again, we have the chain rule happening, so I need to put a negative and a 1/2 in front, evaluating at 0 and b. So that's a negative 1/2 e to the negative 2b power minus negative 1/2 times e to the negative 2 times 0 power. You guys know anything to the 0 power is going to be 1. So that's going to be plus 1/2. It's saying this is equal to, the volume is equal to 4/9, right? Because again, this is the volume, equal to 4/9. So if I move the 1/2 over with subtraction, all right, that's going to be subtracting, let's see, a common denominator would be 18. So subtracting 9/18, that's 8/18. 8/18 minus 9/18 is negative 1/18. Then I want to move the negative 1/2 over with multiplying by the reciprocal, so negative 2. So that's going to be positive 1/9. Now you're very close. I'm going to rewrite this as 1 over e to the power of 2b equals 1/9. This is a proportion. Do cross products, set them equal to each other. So e to the power of 2b equals 9. To solve this, you're going all the way back to your days in pre-cal. So the natural log of e to 2b power equals the natural log of 9. You can move the 2b to the front. And the natural log of e is actually just 1. So b is equal to, how I would write it would be the natural log of 9 divided by 2. All right, the natural log of 9 divided by 2. Now, if you look at your answer choices, you don't actually see that, but there's only one that would make sense with this, which is 1/2 times the natural log of 9. So 21 is D. All right, guys, that's it for the review. Go ahead and take a look at this, and we'll go over it in class.